Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on the confidence interval for the mean. I wish to thank Mrs. Borlaug for allowing me to use this PowerPoint to make this set of videos. In this video, we will concentrate on adding a graphical display to our confidence intervals. It is time to start our first example. The length of parts produced by a manufacturing company is normally distributed with a mean of 700 centimeters and a standard deviation of 10 centimeters. In most manufacturing settings, we would not normally know this. So, we will assume that Beth, and that will be me, does not know the mean or standard deviation of the parts produced, and she wishes to estimate the mean length. She takes a random sample of 6 parts and measures the lengths in centimeters, and the results are given below. And we want to construct a 90% confidence interval for the mean length of parts, and we're going to write a sentence interpreting the confidence interval, and we're going to graphically display the confidence interval for the mean length of parts. In this case, we want to imagine that we're going to take this sample and try to estimate what we know about the population. And in this case, we've done it kind of backwards to kind of explore this problem. And we have these 3 parts to this example: the interval, the sentence, and the graphical display of that interval. So let's start, or I will begin with the interval. Notice the directions. How do we know what to do? We are asked to construct a 90% confidence interval. Look for that word construct. Then we are given a sample. We're not given numbers or statistics. We are given a sample of 6 numbers. So the first step will involve finding the sample mean and standard deviation. We will place those numbers in list 1. We will place 717.6, 697.8, 703.7, 705.4, 700.8, and 699.4 into list 1. Then choose one variable statistics or one var stats on list 1 and get our results. Remember that I have covered this in a previous video. That gives us X bar of 704.1167, a sample standard deviation S of 7.1661, and a sample size N of 6. So to construct our 90% confidence interval for the mean, we have our X bar, or our sample mean, our sample standard deviation S, and our sample size. And we will want to find the lower confidence limit and the upper confidence limit, as well as our sample mean, which we have. Because we are normally distributed, we're good there. And the second thing we want to look at is that we do not have the population standard deviation. Yes, we know the population standard deviation of 10, but that's as a setup to the problem. To construct the confidence interval, we're basing it on the random sample. And so from the random sample, we do not know, or we're assuming Beth, that's me, or the person, does not know what the population standard deviation is. So that tells us that we have that we do not know what the population standard deviation is. Therefore, the population standard deviation is unknown, and we have the sample standard deviation. That means we will use the t distribution. So here are our formulas. And that means the first thing we want to find is our t sub alpha divided by 2. That means we're looking for a 90% confident. That means our alpha is 0.10 or 10%. Our degrees of freedom is 6 minus 1, n minus 1, which is 5. And alpha divided by 2 is 0.05. So 0.05 and then 5 cross and on our table and give us the t-value of 2.015. Placing in our standard deviation and the square root of our n gives us 2.015 times 7.1661 divided by the square root of 6, which equals 5.8950. Remembering that we're rounding all of our working numbers to 4 decimal places. That then gives us 704.1167, our sample mean, plus the error of 5.8950, and 704.1167 minus our error of 5.8950, to give us an upper confidence limit of 710.0117 and a lower confidence limit of 689.2217. Looking at our original data is to 1 decimal place, so we want to round to 2 decimal places. So that gives us 710.01 and 689.22. We will fill those in for our lower confidence limits and our upper confidence limit, as well as filling in our X-bar. And we have our information that we need to go to Part B, which is to write a sentence interpreting the confidence interval. Remember that your sentence will start with, I can say with blank percent confidence that the blank is between blank and blank blank. Well, let's just fill that in. I can say with 90% confidence, because that is the confidence interval we built, that we're talking about the mean what? Length is between 698.22 and 710.01, and we were measuring in centimeters. So there is our sentence. And the third part of our problem is to do this graphically and to make a graphic display for the interval for the mean length of the parts. Now remember that we have in our background, even though we didn't use it to create our confidence interval, that the mean is 700 of our population with a standard deviation of 10. And that is why we've placed 700 in the center of our normal curve, and we've counted by 10 up and subtracted 10 down, and that's where we get 700 in the center, then 710 and 720, 690 and 680 to the left. Notice Ms. Borlaug did go out 2 standard deviations in both directions. From our sample, we have a lower confidence limit of 698.22 and an upper confidence level of 710.01. Those are graphed as estimates, with bars and a dot for the sample mean of 704.12, and that gives us what we have here as a way to graph it. whoops, went too far. Let me go back. Does the mean of the population fall into this confidence interval? And yes, 700 is contained in between the 698.22 and the 710.01. We can see that by looking at the numbers as well as looking at the graph. I thought I could get all of this done in one video, but I'm at the over the 10-minute mark, so I'm going to pause here and we will make this at least a 2-part video set. And thank you for watching this first part. Tune in and we'll discuss this graphical idea and how we can use it to better explain confidence intervals in part 2. Thank you for watching.